Hi everyone, we're continuing with lesson 25. Before we talked about single value point estimates for population parameters, now we're going to talk about interval estimates. Later on, we'll call these confidence intervals. To account for sampling error, we'll provide a range of values called an interval estimate for a population parameter, such as a population mean. So instead of a single value, we'll offer a range of values. Example 2. Let's say a lecture class takes an exam, a big lecture hall class, and we want an interval estimate for mu, the population mean of exam scores in the class. So let's say that I'm the professor of the class. I'm looking around at these 1,000 students taking the test. They're sweating. I notice they're sweating, and I'm wondering how they're going to do. So after the end of the exam, I talked to my TA, Igor, who's going to help grade the exams. Now, it may take several days for Igor to grade all the exams, but I might be curious. Well, that night, how well did the class do? I want a sense of how well the class did. So I'd like to get an estimate for the population mean for the class, the population mean of the 1,000 exam scores in the class. Now, Igor does not have time to grade all 1,000 exams tonight, but Igor could take a random sample of 5 tests, grade those, and give me point and interval estimates for mu based on his sample mean, x bar, and also some measure of spread, as we'll see. So Igor takes the 1,000 exams, throws them up in the air. I duck or I hide under a desk, and Igor randomly selects 5 exams to grade. Remember, just grabbing the top 5 exams off the stack might lead to a biased estimate. So Igor takes a random sample of 5 exams, and Igor grades them. And based on the sample statistics, Igor could give me an interval estimate for mu, because Igor knows some statistics. So a random sample of 5 exams is selected and graded. Our interval estimate for mu could be this interval, from 70 points to 78 points below. So I ask Igor, give me an interval estimate for how well the class did, the population mean for the class, the mean for all 1,000 students. Well, based on his sample and his sample statistics, Igor could say, Master, I'm getting an interval estimate of between 70 points and 78 points. So if I had to guess, I'd guess that the overall population mean for the class will be somewhere between 70 points and 78 points based on what I'm seeing on my sample. And by the way, Igor could also claim that his point estimate for the population mean is the sample mean, 74 points. How do you think the sample mean here compares to these two numbers? Think about that. All right. By the way, the 70 and the 78, those are 70 points and 78 points. Those are referred to as the limits of the interval estimate. 70 points is the lower limit. 78 points is the upper limit. And how do we arrive at the sample mean? Given the interval, or given the limits of the interval, how could we figure out the sample mean? Well, what's the relationship? The 74 is the average of the two limits, the two endpoints of the interval. The sample mean, x bar, is at the center or midpoint of the interval. It's the average of the lower limit and the upper limit. In this case, the 70 points and the 78 points. It's the average of these two values. And how do you take the average of two values? You add them up and divide by 2. And it has the same unit as either limit. You add up 70 and 78, divide the sum by 2, and you get 74 points. That's the sample mean. In this class, whenever we do an interval estimate for mu, a population mean, the sample mean, the point estimate, will be the midpoint. It'll be right in the center of that interval estimate. This will also be true for p hat, the sample proportion, if we're doing an interval estimate for p, a population proportion or probability. However, this will not be true of interval estimates for sigma or sigma squared. So to reiterate, this interval estimate is symmetric about the point estimate, x bar, or 74 points. The 74 points, the sample mean, x bar, is right in the middle, the midpoint of the interval estimate. But this will not always be the case. It is true for p hat and p, and for x bar and mu, our estimation for mu. But when we estimate standard deviations and variances, well, actually, we cannot appeal to symmetry. It turns out, for example, that an interval estimate for variance, at least the kinds that we're going to develop in this class, those intervals will not be symmetric around the sample variance. Same for standard deviations. But for x bar as an estimate of mu, for p hat as an estimate of p, then yes, these will always be at the center of corresponding interval estimates. Next up, we're going to discuss the margin of error, which is basically this here. It's the distance between the sample mean and either endpoint, either limit. That's the margin of error, which we hear about a lot. And we'll talk about that next.